Welcome everybody, and again, thank you for coming out tonight. I know it's on your own time, and we are truly here to listen to what you have to say. And I appreciate the opportunity to have the exposure here in Seattle, as we will have in Hood River and Portland next week. And again, we really appreciate you coming out. Before I get started in an overview, I'll try and keep that fairly brief on the overview of the full site and get into the decisions that we're proposing tonight. I want to introduce the people that are here from the Department of Energy and our contractor groups. So if you do have questions afterwards, you can come and ask them the technical questions necessary. On my right here is Brian Charbonneau. He's the Federal Project Director. On his right is Moses Gerace. On his right is Virginia Rohe. I've got Paula Call in the back. And Paula's got a team with her, Sonia Johnson and Lynn Tegler. If you guys could raise your hands. I'd like to thank them from the start right now. They're part of the public meeting and public involvement group that we use at Department of Energy and with our contractor groups. And they do a lot of work to make this happen and facilitate this. And it's a lot of work, and I really appreciate you guys doing that for us. Before we get started, I wanted to point out a couple things that you're going to see more often at our public outreach, whether it's meetings like this, state of the sites, HAB meetings, wherever we see the public. You're going to start seeing the progress that we're making out at Hanford visually. I know a lot of people, especially from the west side, don't have the opportunity to go over there. When I lived over here, I never went over to Hanford. Just kind of knew it as this big amorphous government place that had a fence around it. And finally getting to understand it, I think a picture's worth 1,000 words. So you're going to see that as we come out to the public, and I hope you take a look at that and question it. If you don't understand what you're seeing, ask what it is, ask what the background was. You know, really ask us and have us dig deep and answer your questions, because that's what we're here for. We serve you as the public, and I take that very seriously. Let's see. Oh, I'm doing this. That's right. Sorry about that. So our agenda tonight, and again, to reiterate the purpose, is we're really here to provide you with the information and receive your input on these decisions on areas 200 CW5, 200 PW1, 3, and 6. We'll get into the details of those later on in the brief here tonight. But before we do that, I'm going to go over the Hanford cleanup approach, and I'm going to kind of drill that down. So I'll start generically at a large kind of high level and then get down to the areas that we're talking about tonight. And I'll turn it over to Emmy to give us some background on these cleanup and remediation sites that we're going to talk about tonight. And then lastly, as I go through the background, the remedial alternatives and the preferred alternatives for these sites, we'll finish with how you can provide us more input and more information, including this meeting tonight. Before we get too far, I do want to do an advertisement. If you ever get a chance, and this is available by DVD that we have tonight, I don't like to print out copies because we're trying to not print out a lot of color copies of stuff, but we do have DVDs that you can take with you tonight. On the Hanford Site Cleanup Completion Framework, this is a strategic document that basically gives you insight on how we look at the site itself. You can understand the priorities by which we make our work happen, by which we look at remediation, and by look at how we execute the resources, that is budget, and resources of our contractors, people, to make this happen on a daily basis. You'll also get out of that document the goals for our cleanup, the challenges that we see, and the relationships that we have between the river corridor, the central plateau, and the tank waste. And those are three distinct different groupings of waste that we deal with. So before we get too far, I want to talk about the overview of Hanford. You see this footprint. It's 586 square miles. You can see the Columbia River as it goes through. And you'll see it broken down into 4 areas. The first area is the green area. It's the Hanford Reach National Monument. It's about 290 square miles. Not much radioactivity, not much contamination. Is it too loud? Here, I'll put it down. Okay, slow down. Okay, I'm going to slow down a little bit too. Is it too loud for people? All right. So the first area is the Hanford Reach National Monument. Not a highly contaminated area, but an area that we're going to be closing and finishing this year. So we're trying to shrink this footprint down. The next area is the river corridor. It's 220 square miles, displayed here in yellow. And that's the area that's adjacent to the river. As you discussed earlier in your workshop, it holds the 9 reactors that are along the river, and it also has the 100 area where they process uranium. before irradiating in the reactors. And then in the dark brown area and the dark red area inside of it is the Central Plateau. And that's really the heart of Hanford. It's 75 square miles, and that inner area, that red area, is called, the inner area is 10 square miles. Basic premise of this is basically if you think of our mission is primarily to protect the Columbia River. That's why I joined the Department of Energy about 3 years ago. That mission, if you think about the contaminated sites and what we're trying to achieve closure on the river corridor by 2015. And so we're trying to mitigate as many of the sites and areas that are close to the river as possible as we move ourselves into that inner area of contamination on the Central Plateau. So it makes a little bit of sense as we go through that, how we're trying to achieve remediation in stages and priorities that will protect that river as best possible. Now that said, at the same time we're doing that, we've got groundwater. And groundwater, I'll talk to in the next slide, but it's an important facet of this. And when you look at the Central Plateau and the river corridor, actually, in the Central Plateau, there's 3 facets of our strategy there that break out the general kind of idea of how we're remediating this waste. You've got the outer area, which we're trying to clean up to the same standard as the river corridor, which is drinking water standard. If we can't get drinking water standard in the Central Plateau outer area, we're going to stop any plumes from reaching the river at all costs. That is our primary mission of groundwater remediation and remediation in the Central Plateau. When you look at groundwater right now, we're about to commission, in fact, Bryant is the project director for one of the largest groundwater pump and treat plants in the world. And that plant will process 2,500 gallons per minute when it's complete. It's a very impressive plant. If you ever get a chance, and I think we've got pictures of it, it's really impressive to see it, and we're going to commission it this year, and it'll start processing waste sometime in March. That's when we expect it to actually start processing water. So that's pretty much the Central Plateau cleanup approach. As you look at the inner area, this is a very interesting slide because it shows you a couple things. It shows you that we're serious about keeping that inner area to as small as possible. And the inner area is different than other areas of the Central Plateau. It's different than any other area of the Hanford site. Hanford site is 586 square miles. This inner area is 10 square miles. It's the minimal, it's what we've designed to be the most minimal footprint we can design and get all of the material that we have to store stored long-term with DOE presence, long-term, controlling access to that site and remediating the waste inside this area. And as you can see, by looking at the chronology, basically, if you will, this is basically defines the boundaries of the inner area. You can see that in 1965, Washington State Department of Ecology defined a low-level radioactive waste disposal. We had a naval reactor compartment disposal defined in 1986. We got through several of these decisions and recommendations that you can see as the numbers progress that go into our U-plant record of decision, integrated disposal facility, waste disposal. You know, all these things have acronyms. These are all basically waste sites. A U-plant was the canyons that they used for refining getting to the final purity on plutonium. And the integrated disposal facility is a giant waste facility. These are all sites where there's going to be material held long-term. The material that's going to be held there is going to be low-level radioactive waste. It's not going to be the true waste that we talk about that gets shipped to WIP. That actually gets shipped to the waste isolation pilot plant down in New Mexico. So when you think of the waste streams coming out of Hanford, it's low-level waste that we are likely keeping most of in Washington, and true waste, which gets shipped down to waste, which is transuranic waste. It's the nastier stuff that we talk about. So if you look at how that footprint is designed, it's not a real attractive shape. It's not a beautiful football field. It's not a square. There's not a lot of inefficiency in that design, and that's why it's designed that way. Because it's defined by the areas that we are going to maintain long-term as the Department of Energy with our presence monitoring those waste sites until we assure that public safety and human health and the environment are protected. As we look at Hanford's cleanup footprint, as I talk about the inner area, It's an area that we're going to, we see it differently. It's not going to have a free use of land. It's not going to have a land use that's similar to the areas outside in the river corridor where other agencies might be able to control that land. It's going to be under DOE control. As we look at the decisions that we make there, we're going to make strict risk-based decisions there. Those are decisions that are designed to protect the public, to protect human health and the environment, and again, we'll have a long-term presence in these areas. We're going to leverage, or actually, as we look at those and we come to these decisions and we make these final record of decisions, enter them, and start our remediation, it's important that we continue to make progress as we see our budgets get more and more challenging, our resources get more and more challenging. You all know what's going on with the federal government right now. It's not a scapegoat. I'm telling you right now, I will never use that as a scapegoat personally as a manager for the Department of Energy. And I think it's important that you understand that we don't make decisions on budget alone. When we look at budget and we look at decisions, it falls underneath the CERCLA evaluation criteria that we use after we've met threshold that the decision is a viable decision to make and it's a remediation strategy that it meets the threshold for actually being under consideration. We look at balancing criteria, and you probably can't see these, it's an eye chart. But to understand this, it's really simple, and you can come up and see it after this brief and after the Q&A period. They look at long-term effectiveness and permanence of the decision. They look at the reduction of the toxicity, the mobility, and the volume of that treatment. They look at the implementability. They look at whether or not we can actually do it or not. We look at cost, and we look at the short-term effectiveness to see and balance all these decisions to see if we can make the right decision with the right priority with the resources that we have. This is a challenging year for us. For an example, right now, I'm one of 2 assistant managers. There's a manager for the river corridor and a manager for Central Plateau. I'm at the point where, it used to be pretty good. We could make decisions and be flexible with millions or tens of millions of dollars. I'm down to decisions in the $10,000 and $1,000 range. We're counting pennies. I'm not hiring people. I'm doubling up on people. I'm not going to hire an admin assistant, for instance, because we're trying to be as thrifty as we can to get the money put on cleanup, because we know it's a precious resource. It's not that we squandered it before, but we had a lot more flexibility in research and development and doing other things that were beneficial but maybe not paid out in the long term into remedy efficiencies. We're at the point now where our future budgets are going to make us be lean and mean, and that's the way we have to play. The other thing to look at, as we make these decisions, CERCLA evaluation criteria, well, we're the long-term sponsor or long-term champion of this site. We're there watching it, the custodian of it. We have to do a 5-year effectiveness review on all of these decisions that we make. So as we look at the remediation, we look at data coming out of the wells, the monitoring wells, and the different samples that we take on an annual basis. We look at the effectiveness of the remediation strategies as they go to final decision. We'll actually make an evaluation of their effectiveness, and if that effectiveness breaks down for any reason, we have to go back in and fix it by law. That's what the CERCLA law does for us. It doesn't happen very often because usually these decisions are made properly. But I think it's an advantage because being there long term, who knows what types of remedies we'll be able to leverage 100 years from now when my son's son is working at Hanford trying, being a guardian of this kind of activity and the remediation decisions that we're making today. So it's food for thought. I'm going to leave on this slide, and then Emmy's going to come up and talk about the background of the actual sites we're talking about. But this is the CERCLA process. And as you go through the CERCLA process, it starts with a site inspection. We get sample data, but it's not just sample data. In fact, a lot of the information that we know about Hanford is process data. It's records and history of what went into what tank, of what facility processed what, and what ditch was used for what. And that's where we get a lot of the quantities that we know. That's where we get a lot of the characteristics of the plumes and the cleanup extent of condition that we have to take care of. And then we try and validate that as efficiently as possible with our sampling. However, we wouldn't be here unless we felt we had enough information to make a final decision. So it's not that we don't have enough information. It's that we characterize that information and make the right decision to protect human health and the environment for as long as, for forever. So looking at the site inspection, we get all that evaluation. We go into a remedial investigation. That's where we collect all this data. We kind of analyze what the extent of condition is on each of these sites. And then we go into a feasibility study, which evaluates the risks and starts to develop the proposals before we get to final proposal. For the PW1, 3, and 6 and CW5 site, we actually brought this to the public 2 years ago, 2008 and 9, and we received your input. We actually made changes to the strategies that we're talking about tonight when you see the preferred alternatives with that public input. So if you don't think it matters, it does, and we listen to it. And so it's important that you keep coming to these things and keep giving us your input, because we're listening. So at this point, we're now at the proposed plan, and you'll see it right here. We've gone through the different options of treatment viabilities and treatment options, and we're now at the process where we've determined a preferred alternative with our partner, the APA, in this decision, before we go back to the tri-party agreement and review all the public comment that we get and come out with a record of decision. So the next stage after this is that after we finish our public comments, we'll go in with the two other parties in the tri-party agreement to make the record of decision. Once we have the record of decision, it addresses public comments. We'll get into the remedial action, where we'll go through the design and the implementation of the remedial action. And then once that's complete, it gets into the 5-year review cycle for reevaluation to evaluate the effectiveness and efficiency. So on that note, we're going to get into the actual area analysis, and Emmy's going to give you a background on that. Thanks.
Can you hear me all right? Yes? Okay. Hi, everyone. My name is Emmy Laiha. I work for the Environmental Protection Agency. I'm the project manager for the 200 PW1, 3, and 6 waste sites. And I just wanted to take a few minutes to talk about how these waste sites became contaminated. So JD was talking to you about how the Hanford site is split up. We have the river corridor and then the central plateau and the inner area. The inner area is actually divided in half. We refer to it as the 200 west area, which is on that dark red area on the left-hand side, and then the 200 east. The waste sites that we're talking about tonight that are located in the 200 west area have primarily plutonium contamination. And then those in 200 east are different because they have cesium contamination there. So we'll start breaking it down into more detail. When we're looking at the inner area, or the central plateau, the Hanford site, keep in mind that there's over 800 waste sites and facilities located here. Hanford is very large and very complex. So in order to make it more manageable, we have to break it down into smaller units so we can plan cleanup appropriately. It's kind of how the old saying goes, how do you eat an elephant? Well, you eat it one bite at a time. So that's what we're trying to do here. We're looking at these 21 waste sites. As I mentioned before, the ones in 200 West on the left side of the screen primarily have the plutonium contamination. So JD actually stole a bit of my thunder. There were a few points I wanted to make here. One of those was being that we're looking at sites that are where the soil is contaminated. Of course, we have groundwater contamination at Hanford also. As JD mentioned, we have a large system being put into place to address that. So we're just looking at the soil contamination in these waste sites. And let's look at how the contamination got there. This graphic here is depicting the activities that happened that led to these waste sites being created. In the Central Plateau, we had large facilities that process plutonium. So from those plutonium production activities, we had large amounts of liquid waste that were discharged to the soil. And those waste streams were different depending on the activities that were occurring. So those characteristics of the waste streams actually identified how we broke up the sites into waste groups. If you looked at the proposed plan or the fact sheet, we refer to these waste sites being in the Z ditches or the high salt or low salt sites, or in the cesium-137 sites. So for the Z ditches and low salt sites, that liquid waste contained primarily plutonium and americium. That waste, it stayed for the most part near where it was discharged. It didn't travel too far down into the soil. In the high salt waste group, there's 3 waste sites in there. That waste was actually highly acidic, and that allowed it to travel further down through the soil column and actually reach groundwater. So at one point in time, that contamination was a source for groundwater contamination. So it traveled very deep. The high salt sites are a big player in this cleanup decision that we're discussing tonight. And then we had the cesium sites that were in the 200 East area. There, the waste the liquid waste didn't travel as deep. For the most part, they stayed near the point of discharge, maybe going 28 to 30 feet or so below ground surface. So to give you, I guess to compare it to something more familiar, I would compare these waste sites, the trenches, the cribs, the ditches, to something like a septic system, where an old-fashioned septic system. So you flush the toilet, the solids are removed. We have two waste sites that are tanks that collected solids, and those primarily have plutonium and americium. So that's separated, and then the liquid waste is discharged to the soil over a bed of gravel or something similar to distribute the water, so it runs over a larger surface, and then that allowed it to travel downward. And that's just a quick, these waste sites are actually very complex. This is just a quick summary, but hopefully it gives you a better idea of the type of contamination that we're dealing with. And I'll turn it back to JD so he can discuss our preferred alternatives.
Thanks, Emmy. Yeah, you can take, yeah. This is still kind of precarious here. Okay, so when we look at the waste sites, I think if you had a chance to look at our placards, or if you get a chance to look at them after, you'll understand, and as Emmy said, there's very complex, but at the same time, many of them are very rudimentary. You can see from the dates that they were used, started in 45, after the plutonium was being fabricated in earnest, went through mid-'80s, late '80s, and some of them can be like these plain ditches where they just dug a ditch in the ground of ground and dumped water in it, to elaborate French drain systems where they actually, engineered an actual slope to the sides, put gravel in the bottom, about 2 meters underneath it, and then put a pipe through that with perforations. French drain is what that's called. So it efficiently distributed the water along that whole ditch. But you'll find that when you look in the RIFS documents, you'll see that there's a number of different geometries. It's kind of interesting to see how they developed, but they're very rudimentary, and they were very effective. They got the stuff into the ground effectively, and that's the problem. So in characterizing 200 CW5 operable unit, you can see it's made up of 5 different types of things. There's 3 open Z ditches, and they're called Z because of the configuration they made across the actual site itself. And then there's a tile field, which is kind of like a ditch with a tile lining that's buried. And then one unplanned release site, and that, to explain it quickly, it's basically they were digging another Z ditch, found out they were too near the contamination of another site, and had to move it, but used that to dump material anyway at the same time. So nothing mysterious there. This received the cooling water and steam condensate from the plutonium finishing plant. That was part of the processing. So you say to yourself, well, steam condensate is typically in a single loop, and it's protected. But these actually occurred when pinhole leaks would develop inside that system and leak some of the plutonium out. And those were either not fixed, not caught in time, and related and ended up with this type of contamination as it was flooded into these various tributaries of the ditches. The contamination located primarily at and below the bottom of the ditches. Most of this contamination is within 15 feet of BGS, the topsoil, the top layer of ground soil. So they're shallow, if you will, relative to where they are in the soil spectrum. The primary risk drivers, as you can see here, are americium-241, plutonium-239, 240, cesium, and actually radium as well. So when we look at the alternatives, some of these are required by the CERCLA process each time you do one. For instance, the first one there is no action. Don't do anything. They're always required to do that as a comparatory. So these are the different things that we did and we looked at. And no action was the first one. Maintaining the existing soil cover and institutional controls is another one. And that's the existing soil cover. That's not a cap or an engineered soil cover. And then putting institutional controls so nobody could get into it. So that's another option we looked at. Remove, treat, and dispose is another option. It's self-explanatory. And then engineered surface barriers are actually barriers like evapotranspiration barriers, which are designed to put plants and other material that will evaporate the water and then put a layer of some kind of non-permeable membrane underneath several soil layers, and then underneath that, sand and other soil configurations so that water can't get to the bad stuff to drive it further into the ground. To get stuff into the ground, you have to have a driving force. And water is typically that driving force. We'll talk a little bit about that as Emmy talked about the difference between high and low salt. It's a good setup for when we get into PW1. But for this area, an engineered surface barrier would be something that doesn't allow the rain to penetrate the ground and drive that material deeper. In situ vitrification. Vitrification means to glassify, to turn it into glass. In situ vitrification, they take large electrodes on a diagonal pattern across from each other, set a voltage through those, and it actually melts the material in between it. It melts the soil so that you have a glassification that holds the material in place and is designed to keep it there. And then there's combination of alternatives. For this case, we chose to remove, treat, and dispose. So it means that we'll be removing as all the contaminated soil present that maintains a risk to human health and the environment. That's just, like I said, about 15 feet. We'll treat it, and then we'll dispose as we require. It goes either to ERDF or to the WIP site if it meets the true requirement for shipping to WIP. As we look at 200 PW1, 3, and 6, basically 16 underground engineered liquid waste disposal sites, same kind of thing, but the difference on this one, this is important, is that we're going to organize the preferred alternatives into these types of alternatives: high salt, low salt, settling tank, cesium-137, and other sites. That's a potpourri of different kinds of things, and we're mixing elements like cesium-137 with the configuration or the element status, like high and low salt. And then we're also mixing in a geometry of how it was done in a settling tank. So bear with me, it'll make sense. And of course, we can amplify it in the question and answer period. These were all during Hanford site operations, typically coming from Z plant, which was the old PFP, plutonium finishing plant, the new plutonium finishing plant. And then for cesium-137, which is the one, kind of the orphan on the eastern side, that came from the Purex plant. So the primary risk drivers here that we identified are plutonium, americium, and carbon tetrachloride. One thing about carbon tetrachloride that we have in place that I'll talk a little bit about later is the system that we use for mitigating it. It's the, I want to get the acronym right, so I'm looking. It's a soil vapor extraction system. And that sounds pretty fancy and everything like that. It's really basically just a vacuum on the surface that pulls carbon tetrachloride out as a vapor, which is very effective, and transfers that vapor back into a solid form. To date, we've pulled out almost over 175,000 pounds of carbon tetrachloride from the ground in these areas of PW1, 3, and 6. So it's an effective measure that has proven itself, and we continue to use it to this day. I think we started that 1991. So that's that third site that we talked about with PW3 with cesium-137. That's the last bullet. So looking at the alternatives that we evaluated, again, there's only two differences between this and the previous slide I talked about with CW5. And the first one, and I was doing this before, but I've got this little pointer thing. Okay, there it is maintain or enhance existing soil cover. And then the other one is soil vapor extraction. Those are the only two differences. And then we don't have a combined alternative on this one as well. And you can see the rest of this. I don't want to talk through it again and bore you. So for the preferred alternatives for high salts, Emmy illuminated the difference between high and low salt. It's an important difference. We found that the low salts really didn't penetrate the ground very deeply. The high salts did. The mechanisms by which those, that plutonium moved is still under study today, but we have a fairly thorough and good understanding, we think, of how that happened. Number one, it has to happen in acidic conditions. Number two is highly linked with the ability of the carbon tetrachloride to also penetrate through that soil column and pool down in the caliche layer where it sits today right now. And if you look back there and you get a chance to look at the placard, you can see those purple areas are where we have modeled and where we have sampled, in some cases, to verify where that material sits. And those actually depict graphically what we're talking about tonight. So in our case, we did a combination of alternatives. It made complete sense to continue to operate the soil vapor extraction system and continue to vacuum effect, basically pull that carbon tetrachloride out of the ground. It's cost effective, it's very effective, it's a no-brainer. We evacuate the highest concentration of contaminant soils and dispose of as required, and we're going to 2 feet. That's the extent of recovery that we're going to make on this area after we remove the structure. So once we take the structures out of place for these high salt burial grounds, we're going to actually take 2 feet of material out and process that in the appropriate burial facility, either ERDF or WIP. And then we're going to backfill the evacuated area with clean fill. I want to make this clear because I've seen some things that say we're going to dilute the material, we're going to dilute plutonium to get into ERDF, and that doesn't make a lot of sense to me. We never mix clean soil in with plutonium to try and down blend it. We don't do that. So we do have clean soil available because after we excavate, we backfill with clean soil. So I hope there's no misunderstanding on that. And then lastly, we're going to construct an evapotranspiration barrier on top of it. Like I said, that's designed to prevent water from driving the material any deeper than it is already. For the low salt group, also these are found in PW1 and PW6 areas. Going to remove a significant portion of the plutonium contamination, dispose as required. It's basically RTD, and apply an evapotranspiration barrier there as well. This will recover most of the material. For 200 PW3, which is the cesium group on the eastern side, the plan is for us to enhance the existing soil cover or maintain the existing soil cover, so we provide a 15-foot barrier over that material in perpetuity as long as we're controlling the site. For the 200 PW1 and 200 PW6, which is kind of the mixed group or the settling tank waste group, plan right now is to remove the sludge and liquid containing the plutonium and americium. That's RTD. Basically, we'll retrieve. We're going to have to treat this material so that it's in a configuration that we can process and actually bury or send to WIP. And then we're going to dispose of it to the appropriate site as required. After we're done with that, the tank's empty. We're going to grout it, which means cement is grout, basically grouted in place. And lastly, on 200 PW6, other site waste groups, no action on the French drain system in Z8 or the injection reverse well system in Z10 because we can't find the soil contaminations required or necessary for us to have to provide any protection. They're just not there. These sites were designed to get that material down deep. We have not been able to find it with our sampling. So that kind of, that's where that stands. So it doesn't, there's no reason for us to provide a remedy that protects human health and environment in that case. So providing input, you can provide input tonight. Everything goes on record. Your comments will go on record. You can write it down on a piece of paper for us tonight. We have that email address right there. The public comment period is open until August 5th. If you're in Hood River or Portland next week, Tuesday night and Wednesday night respectively, you can show up there and do the same thing if you'd like. You can call us. We'll take your comments any way we can. In fact, Paula Call and Sonia and we're here to take those comments. And those comments go into that public record that we use to actually sit down and determine whether the decisions we're making are adequate for the public. So in looking at this, we expect to be at a record of decision and have the comment responses by the end of this September. It's an aggressive schedule, but we're on track for that. And we look forward to your comments. Thank you.
Thanks, JD. Thanks, Emmy. Jerry, you are up. Do you want to go now?
Sure.
Go
Sorry,
real. Yeah. No, go real quick.
Sorry, earlier I didn't get a chance to give EPA's input on the preferred alternatives that were identified. With EPA, our main mission is to look at or to ensure the protection of human health and the environment. And in looking at these alternatives, we've determined that they are protective of human health and the environment. JD also talked about the CERCLA process and how there's all these different criteria that we look over. I will mention that community acceptance is also one of the criteria we have to evaluate when picking an alternative. So your input tonight, well, it is of importance, and we do need community acceptance to be able to agree on a cleanup remedy. So I do encourage you to submit your comments because they do make a difference. Thanks.
Thanks, Emmy. So the agencies went a little over, Jerry, so you can go a little over too. Facilitator discretion.
So,
Couple of minutes. We do percentage-wise. Jerry gets a couple
good to see
extra
you again,
minutes.
around, Dennis. Is this on? Can you hear me okay? Okay. Right. Which way is forward? Right. So, Heart of America Northwest is the region's largest citizen watchdog group, and we work with other citizen groups across the region and are presenting an alternate viewpoint this evening as part of the process. And tonight, as you can imagine, we really have a rather dramatically different viewpoint. And our viewpoint is one that coincides very closely with the view of the regional consensus adopted by the Hanford Advisory Board, 32 seats representing very, very diverse interests all across the region, which has urged the Department of Energy and the regulators to go back and propose a retrieve, treat, and dispose remedy, not leaving waste, especially plutonium, in place. And what we're talking about tonight is waste sites with enough plutonium to make more than 70 nuclear weapons from scratch in the liquid waste discharge trenches. So what you have here is pie chart. The 562 is the kilograms of plutonium that the Energy Department's own estimate is for inventory in the soils of these units for liquid waste discharge trenches, cribs, trenches, etc. 100 kilograms is the amount of plutonium in the unlined, leaking commercial radioactive waste dump in the center of Hanford, next to the cleanup landfill where they say they'll put a bunch of this. And 371 kilograms is the amount of plutonium the Department of Energy estimates is in the 43 miles of unlined soil ditches used to dispose of solid waste. We're very concerned that if the Energy Department doesn't dig up the waste in the liquid waste trenches, they're not going to go and dig up the waste in the unlined soil ditches either. So we call the sites the liquid waste discharge sites, not CW5, PW1, and we encourage you to send in comments and to come back to public meetings on revising the public involvement plans for Hanford later this year, to encourage the agencies to use plain language in describing these sites instead of things like CW5, PW1 proposed plans. We're not just talking about plutonium tonight, as you've heard. There are massive quantities of extremely dangerous, carcinogenic, neurotoxic, reproductive, etc. chemicals that were dumped here. The amount of carbon tetrachloride that was dumped into these trenches is mind-boggling. The amount taken out by soil vapor extraction, while nice, is a minuscule fraction and will never, never approach the levels necessary to protect the groundwater and to prevent the carbon tetrachloride, the dibutyl phosphate, the tributyl phosphate, the hydroxylamine nitrate, which they don't even mention, from mobilizing plutonium, cesium, and the other radionuclides and moving them to groundwater. You've seen where the waste sites are. And here's an inside of the Z9 trench, which, as was mentioned, this is a cement lid over the trench 120 feet wide. Think about that, 120 feet wide. It's 20 feet deep. Over 127 pounds of plutonium was removed in the 1970s from just the top 30 centimeters of soil in this trench. Enough to make a dozen nuclear weapons, and there's a massive quantity of plutonium left there. And this is one of the trenches where the plutonium is acknowledged to be over 100 feet deep. How do we know it? In the 1970s, it was 100 feet deep. We have no idea, actually, and they've done no testing to see how much deeper it's gone. The proposed plan is to just dig up 2 feet below the level of the bottom of the trench. 2 feet. The testing of these ditches, you heard them talk about a remedial investigation. I'd actually like to know how much money was spent on this investigation. An investigation that involved a single borehole this decade, and it's taken us this long to find out what the proposed plan is, taken years to get here. There's one borehole for 2 miles of ditches. The rest of the data they're relying on is from, get this, 1959 and 1970. So the waste barely had any time to move by 1959. By 1970, it had moved only for a crib had ended, I believe, in 1962. It had already gone down 100 feet. What makes us think that it's still only at 100 feet? What makes us think that the other ditches don't have massive amounts of contamination deep below them? This is not an investigation worthy of the word investigation. Here we have a map of the Z9, the trenches here. So this is the area that they characterized in 1959. Next slide shows the area they characterized in 1979, and pardon the how it number didn't fit in the box. And then we get to, here's the sole extent of our remedial investigation, a borehole, 2002. Taken them 9 years to get us results to say we're only going to dig up 2 feet. That's worth our money. The proposed plan for the cesium sites, cover up, not clean up. What makes us think that in 50 years, much less 100 years or 500 years, contractors for future developers aren't going to dig utility lines through these sites because there won't be a fence there won't be a sign. We should be doing the responsible thing and digging them up. And when we dig up these wastes, the plutonium should not be going into the landfill. It needs to go into the deep geologic repository. Yes, the Energy Department planned to have a repository, the salt mine in New Mexico, called WIP, that doesn't have nearly enough capacity for all the plutonium in the soil at Hanford and its other sites. So you'd think maybe they'd go back to the drawing board and propose to expand it or an additional repository. Instead, they're saying what we dig up, we'll put in ERDF. And they are talking about essentially averaging the samples in order to put it into ERDF. The proposed plan is based on a myth that plutonium and cesium doesn't move through the soil. A myth busted by the fact that 40 years ago, the plutonium was 100 feet deep. The cesium from high-level nuclear waste tanks we know has reached groundwater. So what makes us think that the cesium won't move from these waste sites, or the plutonium won't move, or the americium, or the uranium? So many of you, how many of you attended the Tank Closure Waste Management EIS hearings? A bunch of you. Last year, the Energy Department had spent over $40 million doing a model for groundwater, what would happen in the Central Plateau with the wastes, and it ignored all that information for this. Those models showed that the plutonium level in the Central Plateau groundwater will reach 2,660 picocuries per liter from these waste sites, not from the tank farms, from the other waste sites, because it moves, and it's going to move. Here are maps. This one's uranium 125 years from now. Here's iodine moving 2,000 years from now. The waste is going to move in the groundwater, and that's from the Tank Closure Waste Management EIS. And finally, the proposed plan is based on saying, we're going to clean up 2 feet, but trust us, if we find something that is 3,000 picocuries per gram, we'll dig up there. What is the cleanup standard for plutonium elsewhere? Well, here we have the Energy Department's proposal that they're going to clean up if the The level of plutonium in the soil is 2,900 picocuries per gram. Here's what the Energy Department is cleaning up to where we tested nuclear weapons on Johnson Atoll. 2.1, 1,000 times more protective. Here's what we're doing at Rocky Flats in Colorado. Here's what we're doing at Lawrence Livermore in California, 2.5, 1,000 times more protective. We deserve the same protective level of cleanup. I urge you to insist that the Energy Department be required to clean up to the same protective level for plutonium in soil as California is applying at Lawrence Livermore National Lab.
Thanks, Jerry.
So, some thoughts about what you can do. Thank you very much.
Okay, guys. Nope, you're good, man. Okay, so we're now going to move into the question and answer, which is your opportunity to hit the strobe light, to get more clarification or detail on what you've actually heard, and then we'll be doing the public comment period. So during this time, we want to make sure for the court reporter that we actually use the microphones. So you can come up to this microphone, or Sonia can chase you down with this one. And if you're not comfortable asking a question, feel free to write it on one of the 3x5 cards that are on the table and hand it to any one of the agency folks around or me, and I can read it and we can get you an answer. So first question, anyone? Yes, ma'am.
Hello, my name is Margaret Swartzman. Early in your presentation, you talked about processing the water at Hanford, and I'd like a little more information about that, because that seems like, is that possible in my mind?
Fortunately, I have the federal project director that's responsible for groundwater cleanup. And when we talk about the pump and treat systems, I think it's appropriate that Bryant talks about it.
Great. It's a very impressive facility, actually. The first thing that we do is remove the radionuclides through ion exchange. And we go through a bioreactor.
I'm sorry, I can't hear you.
Just a little closer, Bryant.
Okay.
There you go. You're good.
It's a very impressive facility. Construction will be completed this calendar year. The first step of that process goes through a series of ion exchange columns, which is a lot like water softener technology, where we remove the radionuclides. Then it goes through a biological digester, similar to what happens on public municipal waste treatment water. That reduces some of the contaminants and also breaks down some of the organic contaminants. Then it goes through a series of separation processes to remove particulates that might have been formed during the reduction process of the bioreactor. It also goes through a air stripper column, which will remove any remaining volatile organics. And there's a complicated sludge treatment system in which the biological waste products are then treated with a lime material to stop any future gas generation once that's disposed of. Yeah, over the last decade, we've been focused on the concentrated part of this plume. This new facility has a series of wells around the perimeter of the plume, and that is to contain the plume in its entirety until the water is treated. So not only are we addressing the hot spot in the center of the plume, this new treatment system contains the outer ring of that plume as well.
Thanks, Brian. Yes, sir.
My name's Jim Kelly. I'm from Seattle. This is really probably more of a question for the Department of Ecology, the Washington State. as a tri-party agreement party, I'm wondering why the Department of Ecology is not insisting upon the meeting the cleanups, the stricter cleanup standards that are required in hazardous waste law in the state.
I'll just use this microphone. Yeah, thanks. My name again is John Price. I'm with the State of Washington Department of Ecology. And so let me do two things. I'm going to answer your question. First, I want to talk just a little bit about ecology's role at Hanford. So Hanford has about 3,000 individual places where there are environmental problems. And tonight we're talking about just 20 of those. And because there's so many problem areas, we split them up between ecology and US EPA. And so we take turns being the lead regulating the Department of Energy. So the 20 we're talking about tonight, EPA is the lead. But we have an agreement with EPA, and when we're the lead, we consult with them, and when they're the lead, they consult with us. So that's kind of what's going on with this proposal. Just a little bit of background. In 1976, I'm going to tell you where ecology's authority comes from. In 1976, Congress set up the Federal Hazardous Waste Law, and then in 1978, the President signed an executive order that made that apply to federal facilities like Hanford. That's basically where ecology gets our authority from. When that hazardous waste law was passed, Congress specifically exempted Atomic Energy Act radionuclides from that. So that's a gap in our authority. And so when we have radionuclides involved, we rely on US EPA to make those decisions, which is what's going on here. Now, where we have authority, we either use it or we work with the Department of Energy and EPA to make sure that things are being done according to our standards. So for this particular proposal, let me just run through a few of the problems where we feel like our authority does apply or our standards apply. So for the carbon tetrachloride, that is being cleaned up consistent with Washington State standards. The groundwater in this area is being cleaned up consistent with Washington standards under a separate decision. And we asked EPA and DOE to change their decision to accommodate our standards, and they did that last year. The tanks that were mentioned tonight, those are being cleaned and closed consistent with Washington State standards. The plutonium, where we don't have authority, is being cleaned up according to the federal Superfund law that EPA administers. However, last year, Ecology did send a letter to the US EPA National Remedy Review Board, and that's a group of nationwide experts that review big cleanups. And this is a big cleanup because it's over $100 million cost. In our letter, we asked EPA to be biased towards a more robust remedy. So we asked them to do more. And so they have that under advisement right now. And before they make a final decision, they will consult with us and seek our concurrence on this decision. So hope that addresses your question.
Dennis, did you want to answer? Tell us who you are, too.
I'm Dennis. I'm choking up. I'm Dennis Falk. I'm the program director for EPA at Hanford. I just want to make a point of clarification that we're not actually proposing to use 2,900 picocuries per gram as a cleanup standard. That was a number that was developed through the risk assessment process. This remedy is really predicated on, I'll call it a cost-benefit analysis, and we have some slides to show you. So what we did there is, again, people have talked about the distribution of plutonium goes, in this case, from about 20 feet below ground surface down to about 100 feet. And we simply looked at taking out of amount of material, how much would we get out for the amount of given money, because ultimately what's protective of here is the cap that we're going to put over the top. So again, maybe before we go to the actual comments, we can show that curve because it's a little bit telling. And so again, there won't actually be a cleanup level on these particular waste sites established for plutonium into itself. It will really be a mass removal.
Dennis, do you want to show it right now, or do you want to wait? But between
I think we can just wait, but I think it
Okay.
will help people.
Yes, ma'am. I'll grab the mic for you.
My concern is
Louder,
that,
please. And your name?
is it on?
Green on?
How do you turn on? Oh. My name's Nancy Morris, and I have a question in that as the pressures with budget and trying to shows some kind of headway in all this, which is way behind schedule since this is going on for decades. I was just wondering, there's a tendency to change the laws or the levels that are allowed, as they already have done in Japan for the Fukushima disaster. There's a tendency in South Carolina that the lawmakers allowed them to change levels of, to lessen the standards of exposure to radioactivity to accommodate the schedules of people and so on. It seems to me that we're at risk of this. It's very easy for you to kind of hide and doublespeak of what you're really intending to do or what you really feel you're going to accomplish. So I have a question as how you are really going to answer to the public, and if you've already spent $40 million last year on modeling that says plutonium does move, and now you're sort of working on a model that says it doesn't move that much.
I think that's you, JD.
Yeah.
Well, you're
I got it.
changing your standards
I think I got the
already
question.
after even spending $40 million, and you're already trying to budget around $10,000.
Yes, ma'am. And I think I got the question. It's twofold for me from what I heard. And the first one is that I don't know of any laws in Washington State, which I can't speak to, or in the federal government that are going to change the decisions that we're making today on PW 136 and CW 5. This will be a decision based on the laws as they exist today under CERCLA, which the EPA holds the standard for CERCLA, and then we get together with the tri-party agreement to make this decision final after we get the public comment. So nothing's going to change for that decision right now. And then I also don't see anything on the future, budget risk and budget pressure included, that's going to really change any of the fundamental standards that we have on the site right now. I'm being as honest as I can to you. I don't see anything that's doing that. And do you know of anything, Moses? Do you guys know of anything, John, or anything that? So we don't know of anything like that that's putting pressure on us. And frankly, I'll be on the side of the public. I'm part of the public too, to prevent that. I live in that area. My 5- and 8-year-old drink water out of the aquifers of that system. I got a real deep concern on that as well. The second part of your question is interesting, and I want to correct some of the record here because we've kind of referred back to the tank closure and waste management EIS, which is we're trying to bring to a close this year, and that's the $40 million that we spent in the last 3 to 5 years, depending on how you look at it, to come to a decision on the closure criteria, or not criteria, but come to the scoping of the environmental impact of tank closure. And that's a little bit different than what we're talking about tonight, but there's some numbers and figures that we've been throwing around. I want to clarify the record a little bit on that. That document has come to the conclusion that there will be plutonium impacting the groundwater in 2 locations. And those locations are the core zone boundary, and this is 2,660 picocuries per liter in the year 11,848. That's 10,000 years from now. And the source is the 216B5 reverse well, which injected contaminants directly into the aquifer. And no vadose migration was modeled. So this is a model. So it's what we use right now, and it's not part of this decision. And so as we look at the model that this made, it's an unmitigated model. So we know that that material was dumped there. We know that it exists today. We've got samples that show it exists today. We don't see that that sample is mobile. But it's not related to this decision. But I'm not playing a shell game with you. Let me finish real quick here, because I know this sounds confusing, and I know it's kind of hard to keep track of this stuff. So please, if I'm confusing anybody, get clarification so I make it clear. The second source is in the Columbia River shore. I think that's more pertinent, more germane, more dangerous, if you will. 4,250 picocuries per liter. That will show up in the year 2983. The source is the 316-5-300 area process trenches in close proximity to the groundwater and the river shore. If you're, we didn't go through the areas, but the 300 area is the area just north of Richland, right along the river, where they processed uranium before it went into little like cylinders before it went into the reactors for irradiation to take it to plutonium. So the sources for both of these are directly from direct burials close and in proximity to the river. And they're not coming from PW 1, 3, and 6. In fact, the EIS is very clear about Central Plateau. EIS analysis showed that there was no breakthrough of plutonium from waste sites to the groundwater over the 10,000-year period of analysis, and that's by the STOMP model that we use. That's the standard that we're using right now. But let's do a scenario. Let's do a scenario here. We make this final decision today, and we get a better model 10 years from now. The CERCLA process will force me to evaluate the effectiveness of the measures that we design on this final record of decision to assess whether that's going to be good or not. And if that model indicates that there's something that we didn't know, or as we go about the process of getting more information about plutonium and its ability to mobilize inside the layers of soil that exist in Central Plateau, like this one in 2008 from PNNL, which I don't control PNNL. It's an independent group. It's a science group. They don't contract to us. This was actually contracted. I believe this one was contracted out of us. There are several that aren't. There's a group that studies this each year. So they're actively looking at plutonium and how it moves in the soil. The plutonium that we see in Central Plateau is stable. That's all I can say right now. It's what we know. We've got the single borehole that Jerry alluded to, but we monitor it. And the way we monitor it is we monitor it by groundwater. So if we see a sample of groundwater, plutonium from Central Plateau, guess what? We've got to reevaluate that record of decision. And to date, since the time that we've started putting this material in the ground, we've not seen a sample, and maybe correct me on this if I'm wrong, we've not seen a sample in the Central Plateau that shows that plutonium is hitting the groundwater.
Amy, did you want to add anything on the changing standards question, or are you good?
No, we're good.
Okay.
Based on what borehole?
No, it's based on more than that, man. If you look at the charts back there, the borehole is in the last decade. I think that's. I'm not gonna argue with Jerry on that or getting into a discussion about that. It's based on the process knowledge. It's based on samples that were taken. And a borehole basically is a large well that goes into the ground and stops. Doesn't all go all the way to the aquifer. So that borehole is really a stratification layer of soil, so you can evaluate the different soil strata and determine if plutonium is invasive in any of those strata. And so that borehole was specifically targeted to see if we could find the plutonium in that strata. We also monitor the groundwater. So there's groundwater sampling being done as we speak today. And that report is annually made to disclosed to the public. And I think everyone here, Jerry, and I think several of you have probably looked at that each year. And that's what we use to evaluate the effectiveness of the measures that we make on this final decision. That's the process that we're using. It's legal by all standards, by the CERCLA. It's not a de minimis. I don't think it's a de minimis measure. It's doing the best we can with the resources that we have to get on with the rest of the cleanup. It's important for me, not only as a manager of Central Plateau, but also as a taxpayer and one of the public who's served by the measures that we take, to make sure that we're getting this material out of the ground. And for me to do that, I have to use those resources wisely and make sure that they're balanced decisions. And that's what we're trying to achieve here, is a very balanced decision. That's the best I can say about it.
So the goal here is to get to your guys' public comments, and we've run a bit over on the question and answer, but I want to be sure we actually get the question and answers out. So if we got to stay a little bit late, we probably will. Tom, are you up with a question?
Yeah.
Tell us who you are, please.
I'm Tom Carpenter, and I just had a quick question. We heard some figures from Jerry on the amount of plutonium in the soil now. That's, they figure is in there, and how much would be left behind, but I didn't hear anything from the Department of Energy on that. And just wanted to know if you have an estimate of how much is there and how much would be left behind, and also how long the plutonium is dangerous.
Mike, am I still good here?
I think you're good.
Can you hear me?
Actually, you sound like you're off.
Oh, you're right. Probably did. As for the amounts of material that we're going to extract, the best thing I can tell you is, and if you're talking, as we talk about each of the remedies tonight, the preferred alternatives, you can go back and you can see the amount of material we estimate to be in those areas based on our process knowledge, our sampling, and everything that we could find in precedent in history that shows how these areas were developed and used. So I don't have a number. I don't have an exact number. It would be an estimate anyway. It's probably, maybe Virginia, you can help me work on a number while I'm doing this right now. A rough estimate of the number of kilograms of material we're going to leave in PW 13 and 16. But we're going to pretty much recover all the material, all the plutonium material, out of PW 1 and 6, low salt. We're going to take 2 more feet of material, and this is where I need this back on, Sonia. Where'd Sonia go? Oh, wait, here it is. There's the, let's go ahead and make this a little bit bigger. I know I'm in the middle of this thing here, but let me just do this. Oh, it's not letting me do it. Okay. So when we look at this is an example of 216Z1A, okay? And Z9 is another area that we had, and you'll see these placards back there. Just take a look at them on your way out. It shows the rough amount of material that we estimate was in there. We retrieved, I think it was 56 kilograms of material in 1978 out of Z9. We basically took the top 30 centimeters, and that was that nasty looking pit that Jerry had. In fact, you can see the apparatus in there. It looks like one of those crane things that grab stuff. They took 30 centimeters of that material, a total of 56 grams out. And that puts us where we're at today and what we're trying to recover in these high salt areas. We're going to take another 2 feet. Is that an arbitrary amount? No. It's the amount that after we came through the decision, when I talked about the CERCLA process, and we come through this process and went public for comment input on the feasibility study, we received your input. We actually came to the public with a capping strategy. That was legal. That was adequate. It protected the human health and the environment and public safety. It was adequate. We could have stopped there and said, talk to the hand. We're not going to go any further than this. We didn't do that. We listened to what you wanted. You guys are concerned about plutonium. We listened to what you guys had to say, and we're going for another 2 feet. Here's the gist of this thing. It took me a while to get my head around this, so please listen. We're taking 2 feet, but it's not necessarily going to protect you any more than what's protecting you now. And I know that doesn't make a lot of sense, but hear me out. When we take 2 more feet of this material, we're going to get the bed's at about 18 feet. We're going to take two more feet of material down to about 20 feet. And that's 51%. I know you want me to use the pointer again. So I guess it's important for this one. And hopefully you can see this. There's my little red dot. So here we are at 18 feet. That's the amount of material when you extract and you take out the structure. That's basically the bottom of it. Okay? And that's Z1. As you extract 2 more feet, you're at 20 feet. And you see here's the knee curve for where we think the material is at. And this is done by a number of ways. By sampling, there's estimates, again, modeling. But it's pretty exacting modeling. It's PNNL doing the modeling for us, and they're the best in the world, I think, in this. So you ask yourself, well, gee, Department of Energy, why don't you go further? Why don't you go down here to 64 feet? Well, when you look at that, that's when you go back to this balancing criteria. And the reason that we're removing this plutonium in the first place is not to protect the public. It's to protect a worker that would go out there and dig into this material. And oh, by the way, that's in an industrial area that will be fenced and protected from public access as long as I have anything to say about it. And that's a commitment that we're making in that area. It's an industrial area. It's where we have ERDF, our long-term disposal facilities, and it's where we have to have presence so we can continue to monitor the effectiveness of these remedies in perpetuity until we're finished and they're no longer a risk to public health, human health, and the environment. So as we look at the remedies for this, it's not going to provide you and I any more protection. We assess that this plutonium in this site is stable. It's the high salt material, came in with carbon tetrachloride. It was very acidic. When it's at an acidic level of 2.5, plutonium is mobile. We know that, okay? The basic pH of the ground soil in this area is 8. When it gets past 3 to 3.5, it stops. It does not move, and that's what we're seeing right now. Okay, you believe me or not, it doesn't really matter because there's still ongoing studies going on as we talk today, and there's a group that meets every year on this to determine plutonium mobility. If the assumptions in our modeling changes, we have to go back and re-remedy. It's part of the law. To me, either you believe in the commitment that the government's going to be a custodian of this site, or you don't. And if you don't, I can't help you. I feel that we are committed to that. I feel we're going to be there long term, and we have to do that in order to make sure that these remedies, the things like ERDF and IDF, these big sites where we're taking all the low-level waste and putting that in the large trenches that we're engineering and designing for this material. This is where all the stuff that we dig out of the river goes every day. If it's not going down a WIP, it's going to ERDF, or it's going to IDF, or it's going to RPPDF. So that material, we have to be there to watch that material.
Emmy, did you want to add anything to how much plutonium's in there and how much stays or may stay? Or
I wouldn't mind adding just one.
Dennis?
How about I talk just really loud?
That's good.
Again, this isn't going.
It's getting recorded as well.
All right. So again, one of the reasons we set this up specifically this way is, again, to get an idea of mass versus cost. And you can't probably read that, but what it does is you go around that, JD's calling it the knee. If you get down, if I'm reading that, about 30 feet, you're getting about 91% of it.
Yeah.
And so there's another table that we have that then shows the incremental cost. And so ultimately what the federal government is trying to do is balance retrieval of this material to meet public values. We've heard loud and clear again. The mantra coming out of the Hanford Advisory Board is plutonium is forever. WIP was built specifically to take this material, send it there. And so we're trying to balance what is the right amount to do. And again, the way the proposed plan is set up is it gives you a number of alternatives to choose from. And again, trying to help make a balanced decision.
So, Tom, I see you have a follow-up question, but I kind of want to ask.
I have the original question. How much is there? How much is left? And how long is it dangerous?
Okay, so
Those three simple questions.
how much is there is illustrated. It depends on site by site. I can get an aggregate number for you, Tom. We can.
Have a problem with Jerry's numbers? He put numbers up there. He says you're going to leave about half of it there, and it's, what did you say, Jerry? 100 kilograms?
The high salt sites, which are the most dangerous, JD's own slide shows 50% of
So when you
plutonium
Right. I'm not
stays,
arguing about that.
and that is, I forgot how many kilograms are
Closer,
estimated.
Jer. There you
But
go.
the other thing to remember is
I got it.
these estimates of how much plutonium in the soil were already proven to be grossly wrong in the past. They're really old. And the Energy Department increased by threefold from 1996 to more recent years the estimate of plutonium in the tanks, et cetera, at Hanford, because these old estimates were based on claims of how much plutonium went into those liquid waste discharges. And it turned out that they were cooking the books when they were processing plutonium. They didn't want to admit how much was going out the door, right? And so the Department of Energy increased the estimate. And we don't know when you say we're using, and I don't know what the source of these estimates are because we couldn't find them in your documents. They're not easily findable. Where the source estimates are. Of course, we'd only
No, he's
got
asking
the
about the source,
FS,
though.
an RI link, the proper link yesterday, but
Yeah.
so
So let me take one question at a time. Let me go back to Tom's question. So the answer, Tom, is I can't use Jerry's data, but I can get you the data. And the answer is, for high salt areas, it's going to be something similar to what we just saw with the knee curve. Because again, the remedies is not for human health and environment. That remedy is not for public safety. If your point is one of proliferation, you keep referring to the number of bombs that can be made. Is it a proliferation risk?
No, JD, that's not it.
Okay, but what's the point then of bombs?
The point is, it's giving people a reference point for what it is.
Okay.
And it's not just what gets in the groundwater, JD. Plutonium will move. If someone digs it up, like my workshop, we talked about Harbor Island. You've heard me talk about Harbor Island before. Most obvious Superfund site in the Northwest, right there in front of downtown. EPA finishes cleaning it up with an industrial cleanup standard. Everyone knows it's got a cap over it. No one should dig there. 5 years pass. Workers get contaminated, hazardous waste into Elliott Bay, dirt dug up and moved all over the Puget Sound region and used in construction sites and homes. Why? Because those fences that you swear you'll be there to protect won't be there, weren't there just 5 years later. The whistleblowers got fired who said, isn't this a hazardous waste site? They got canned. What happened? It took only 5 years for people to forget. Plutonium moves in the air very readily if you dig it up, right? We know from looking at other sites that it's a concern not only for our movement to the groundwater, but what happens if someone intrudes on it? Native American tribes have a right to live here and use these resources. We expect there will be other development. What will happen? Why are we leaving it there instead of saying, why not use a cleanup standard? Why not say everything over 2.5 or even 35 picocuries per gram belongs to be removed? Why not use that instead of the balancing criteria, which allows you to bring in cost?
Okay, just a rebuttal.
Quick.
And I don't want to go
quick, and then I want to get the last answer to Tom's, and then we need to move on.
Okay, don't want to go into a point-counterpoint,
No.
but we can't really compare the area of Seattle to Hanford. I just can't compare that. It's not fair. We're talking about PW1, 3, and 6 tonight. And as we talk about that, we have to understand that the basic premise has to be that we're not going to allow development to go on in this area. Otherwise, I agree with you that that would not be adequate for the protection for the human health and safety. It has to be, you have to understand that an industrial area is a different area. And
Harbor Island was an industrial area.
So we're going to move on. How long is plutonium dangerous for, JD?
plutonium is dangerous for, it's got a 24,000 year half-life. So it's going to be, you know, eons. Long time. It's dangerous for a long time. It's hazardous. It's an alpha emitter. Has to be ingested or inhaled. It's not like gamma. You can put a sheet of paper between you and an alpha particle and you're protected. So it has to be airborne. That's why this material, you have to understand two assumptions. Number one, it's protecting a worker who comes into the industrial area that we are going to supervise long term. We're there for the duration of that material being a risk and protective to the human health and environment. And you have to agree that by the studies that we have, and these are available, that what we know right now, plutonium is not mobile like you talk about it is, at the PW136 area. Our own EIS talks about the two sites that I talked about that don't exist in these areas, but will be decisions that we have to make that talk about how to mitigate plutonium in other areas. And that's a different area. We're talking about a different decision tonight where plutonium is stable. I'm not going to say it doesn't move. I'm going to say it's stable. And by our estimates and our modeling, it's stable beyond 10,000 years, which from a half-life perspective, you know, we're kind of getting into a virtual ethereal space in 10,000 years. We don't know what's going to be here. We don't know what technologies will be able to mitigate risk to human health, risk for other things other technologies that we can bear to these remediations. So it gets more complex when you talk in the out years like that. The industrial area, though, cannot be used for general use by the public, can't be used for things like you talked about with tribes and the areas like we're talking about using in the river corridor. It's a different area. It's a different place, and it has to have different rules, and that's why we find it protective, and that's why that preferred alternative is being forwarded. So we took 2 more feet of material because the public wanted more of that material out. If you have any input on that, give us your input tonight. That's why we're here. So please, feel free to make that comment.
Your question and your name, sir. Please.
My name is Eric Buer. I'm a resident in Seattle. And I just had a question. You mentioned the DOE presence long-term at the Hanford site.
You have to hold it really close.
Do you have to really eat the mic?
Yeah.
Van Halen style. Whoa. Okay, so you mentioned a second ago the long-term presence of the Department of Energy in the inner core part of the Central Plateau. And I was just wondering, as part of this proposed plan, are there plans in place beyond, say, like 100 years, like when we talk about long-term institutional controls? Plutonium is 24,000-year half-life, so that'd be roughly 240,000 years for 10 half-lives of decay. Cesium is 30 years, so that's on the order of 300 years for complete decay.
What you're saying are a little fast.
Oh.
And a little closer.
A little closer. So I was asking, usually radionuclides, we wait roughly 10 half-lives for them to decay completely. Is that
right?
Right. So plutonium, you could guess it would be roughly 240,000 years for complete decay, and cesium would be roughly 300 years. And I was wondering what sort of, if part of this proposed plan or as part of DOE's long-term presence, if plans are in place for a presence that's that long. I mean, if you say you're going to put up a fence in the next 5 years, I completely believe you. But I'd like to hear more about what you're going to do to maintain it for 300 years, which the U.S. hasn't quite hit that age itself yet, or the longer term, the 240,000 years. Is there a plan in place to fund that? Is there a plan in place for that sort of longevity? I mean, the DOE is a descendant of the Atomic Energy Commission, I believe, right? So I mean, like, you guys have changed names. Will you change your other strategies for maintaining your control of the site, if that's what you need to do in order to, basically protect public safety as an industrial area?
Right. There's a document called the Comprehensive Land Use Plan that talks about how the different areas of Hanford will be released, or I guess it's not called released because it's always going to be under federal government. And then there's in that document it talks about the inner area that we're talking about here today. It doesn't talk to the specifics about the size of the fence. Doesn't talk to the specifics about a fence. It talks to the specifics about the controls necessary to prevent the risks that we have to the specific worker that would be involved in that area. It's not a public access area, so it's a worker. So, and I believe, and this is off the top of my head, is someone who digs for a certain period of time. I think it's 2 weeks, and it mitigates that person by having a specific amount of distance to be determined between him and the material that could harm. So in protecting what I would call a co-located worker, it would be standoff distance to the material that's in the ground. So it's not public access. It's not going to be an area where, Fish and Wildlife is going to control it, or the Department of Interior is going to control it. It's going to have to be a separate area that the Department of Energy controls and maintains for as long as we need to monitor human health and public safety in the environment.
Emmy, do you want to add anything on long-term federal presence?
On the institutional controls, I just wanted to add that in the record of decision, in the actual decision document, there will be specific requirements that we will hold DOE to as far as how big is the fence, what type of ICs are in place, and that authority through EPA will allow us to ensure that they're meeting those requirements. So as long as EPA and DOE are federal agencies, will have that relationship in place. So it's not just this, there's this document that talks about it. There will be hard requirements that will be specified in the ROD by EPA that DOE will have to implement. DOE will have to implement.
Go ahead.
Thank you. Yeah, I can hear you. Okay, sorry.
No, I'm not actually that interested in the height of the fence. Like I said, if you guys say you'll build a fence, I believe it. But in the comprehensive land use plan or these other, these long-term plans, is there anything that specifically says, what you guys are going to do, not the controls that are required, but what you're going to do to maintain them for something that long? I mean, that usually you guys look at about 100 years, which is possible. But is there anything in place? Is there any written document or anything else that specifically says, this is what we're going to do 250 years out, 300 years out, 500 years out? Like, because part of the DOE presence on the site is you said you'd maintain these covers, you'd maintain 15 feet of soil as long as the site was dangerous. And I'm wondering if there is any sort of actual hard documentation on how you're going to do that long term, like just the funding, just the logistics of maintaining your presence for that long. Does that document exist, or is there any sort of plan in place where someone could look that up?
Paula? I was going to say CERCLA.
Just about a year ago, we went through a process of updating our long-term stewardship plan, which is, I think, what the document you're asking about is. And so I can get you that link, or I can give you my card and I can get that to you. But that is it's called the long-term stewardship plan, and it lays out a foundation for how DOE, currently it's called the Office of Legacy Management, actually takes over these sites once all the remedial actions have been completed and the institutional controls are in place. So as far as long-term funding is done annually through the congressional appropriations process. So DOE has got to make it, part of the annual funding requests that goes to Congress and the President. Here's what it will take to pay for these institutional controls to keep them going.
So I want to check in and just see a show of hands. We're running late on time. I want to see how many more questions we actually have. So we have one back here, and then okay, Jim's got one follow-up. And no, go ahead, and then we'll go to Jim. And is that the end of the questions? Then can we go to public comment at that point? Okay, cool. Go ahead.
So Jerry said something about
and can you give it?
Yeah, Native American treaty rights.
Can you give us your name real quick? Sorry.
My name's Jacinta. I'm a student at the University of Washington.
Thank you.
So what I really want to know about is why there isn't any tribal representatives present at these public meetings, and also just kind of the intricacies of your guys' relationship and how you guys deal with the overlap of treaty rights and your guys' CERCLA protocol.
Yeah.
Does that make sense? I
got it. This is a pretty straightforward answer. They have treaty rights. They're recognized as sovereign states, sovereign governments. So they may show up at public commentary, but they don't consider themselves as part of that public commentary group. We actually reach out to them separately. We sent them letters, 2 letters basically. The first one about, I'd say 6 months ago, another one this month, saying that we were going out for public comment on PW 1, 3, and 6, and that we would like and solicit their comments as well. I've got the Nez Perce comments with me tonight. We have not received comments yet from the Yakima or the Umatilla Situr. So we treat them very similarly and solicit their input for these decisions, and then brief them separately.
So do you guys have like a liaison to the tribes?
We absolutely do. We absolutely do. Her name is Jill Conrad.
Jill Conrad.
Right.
All right, great.
Okay, Jim, last follow-up question, then we're going to go to public comment.
Jim Kelly again. Okay, well, you were talking about these institutional controls, which all of us, I think, are expressing real doubts about, whether our government even can last, this number of years. Now, I think the point is that while you're in the ground digging, should you not be pushing to try to get as much of these materials removed? Because there's obviously, you're talking about cost benefit. Weighing a cost benefit on this stuff. And if you even look at the chart you put up to illustrate that, I can't see any plausible argument for not even going 2 more feet, right? Because you get another 30% of the plutonium out of there if you go 2 more feet. Now the point is, I'm not arguing for going 2 more feet. I'm arguing for going as far as you can to get as much of that plutonium out of there, because you know darn well that we have no way of assuring that we're protecting future generations beyond, maybe your own progeny, my own progeny, but several generations down the road. We can't guarantee that in any way. So now that we have an opportunity and we're in the ground, shouldn't all of us be working together to try to get as much of that out of there as we can?
Jim, without letting JD answer, can I actually say that's a really good segue into that sounded really more like a comment than a question. Can I just make, well, we can have him answer, but can I make the note for the court reporter that you would like that included in the comments? that you're arguing for removing as much as is possible. And JD, if you have a response, go for it.
Yeah, it's just reiterating what I said earlier. It's not going to protect human health and the environment any more than it does now. But it's a good comment that you have a concern about reclaiming more of the plutonium out of the ground. I'm listening to that comment.
Any additions, Emmy? You good?
Oh, good. Very good.
Okay, so I'm going to ask that, again, we're going to continue to use the mics, and please mention your name. And I'm going to limit folks to 3 minutes just to ensure everybody gets a chance. There's nothing saying you can't come back a second time after everybody has had an opportunity. And if you're not comfortable with coming to one of the mics, on the back of your agenda, there's actually opportunity for written comments. So feel free to just fill that out and drop it with one of us in the back or Sonia, and we should be good. So who wants to go first? Tom.
So again, my name is Tom Carpenter, and I'm the director of Hanford Challenge. Put a lot of thought into Hanford over the years, and this really seems like an easy one to me. As US taxpayers, we spent, according to the Brookings Institution, about $5.5 trillion to make nuclear warheads. A lot of that money went to Hanford. Hanford made the plutonium for our nuclear arsenal in about a 45-year period. And in that time frame, also left us this legacy of contamination. These waste sites are dangerous for many, many years, as we've been hearing. I want to put some perspective on this plutonium. It's acknowledged that the very small amounts of plutonium, if it gets into our system, can cause a cancer, a speck, a microscopic quantity. 15,000 years ago, the Hanford site was 200 feet underwater because of glacial flooding, the Great Waluki Flood. Well, it turns out that event of ice age, the retreat of the glaciers, big glacial floods follow, that cycle repeats in eastern Washington hundreds of times, as far as geologists know. They're huge, massive floods, and there are water rings in the hills and mountains around the Hanford site and all over eastern Washington, way up from that event happening. In other words, it's not a stable geological area. It's going to be inundated again. We're overdue for one of those ice ages coming up, and we can expect to see, maybe not in our lifetimes or our kids' lifetimes, but the geological profile of the Hanford site change from what it is today. So based on 30 years of studies, we know that plutonium won't move. I don't buy it, and I think it's absurd to think that we have institutions that will last dozens of years or hundreds of years or thousands of years, that will be there to make sure that nobody goes in there, or that it's protected from flooding, or that we can stop an earthquake or a volcano or whatever can happen to that area. So I think Hanford is simply a very poor candidate for the long-term storage of nuclear waste of any kind and of any quantity. Therefore, there needs to be a very rigorous effort to make sure that all the plutonium that we can remove from that site is taken from that site and processed and treated and put into a deep geological repository, even if it costs a lot of money. It is not the most important thing. This stuff is dangerous for 250,000 years. And there's nothing we know about how to neutralize that, except let it decay away somewhere far away from us. I think that we need to take a longer view of this, less of a, gee, this is driven by money, we got to balance this against our budget. Look at the $5.5 trillion that we spent on nuclear weapons and do the right thing here. I'm going to be submitting written comments that are much more extensive and a bit more technical than this, but those are my major comments, and Jerry alluded to the fact that the Hanford Advisory Board had an excellent set of comments, which we also helped develop and are part of, and think are a great set of comments as well. And they're on the back table over there if folks want to see that. Thank you.
Next comment. Oh, great. Please give us your name.
Hello? Okay, awesome. My name is Lindsay O'Brien. I am an intern with Heart of America Northwest. Jerry's my supervisor. I just started the externship, so I'm fairly new to what's going on, to the issues that have arisen with Hanford. But when I reviewed the proposed plan, I basically focused on the settling tanks. Those are located, if you guys look at the map on the proposed plan, on the northwest side of the map. And basically, I have two main issues, which actually I have several issues, but the main issues are with the proposed plan, which I hope will be addressed, is first, the information provided about the contaminants present in the settling tanks is either lacking, outdated, or just simply confusing. So, for example, the primary contaminants described to be found or supposedly found on the settling tanks are plutonium and americium. What about other contaminants? There is nothing in the proposed plan stating what other contaminants, what other might either are there or might be found. Just because a contaminant's not primary does not mean that it's not harmful, does not mean that it does not pose a risk. And also, according to all the information that I read, and I did a lot of research these last few days, there's no testing, at least no proper testing has been done. At least nothing in the research and the paperwork does it state that any testing has been done of the settling tanks currently to let us know what contaminants are there. The only testing that I found out about was a characterization, and I'm not sure exactly what that means, of one of the tanks in 1984. 1984. I was born in 1983. I'm 28. 27 years, 3 decades. Trust me, that's every birthday I realize how long that is. Technology has changed drastically. I believe that today we have better technology to do testing. Therefore, the only testing that has been done is just not sufficient, and not sufficient to basically really tell us what's going on, what is present there, and also what remedies we should look for in dealing with it. So, for example, we find out there's other contaminants. What remedies are we going to apply here? I actually had a slide this morning, but I had a little fight with PowerPoint and PowerPoint 1. And so I will pass it around if you guys want to take a look. It's basically a little chart that I did, which lists the primary contaminants which are listed on the proposed plan. And next to them, like the 3 columns to the right, there are other contaminants, which I believe, according to the information on the proposed plan, which is all over the place, that are likely to be found in the tanks. So for example, one of the settling tanks, waste used to go through that tank prior to being discharged into one of the low salt cribs. So since those contaminants have been found to be in those cribs, I don't think it's unreasonable to expect them to be present in the tanks as well. Also, excuse me, my second issue is that due to the lack of information, due to the lack of testing, basically new remedies need to be come up with. New remedies need to be analyzed. Excuse me. one of the remedies that was listed on the power, actually the only remedy that was listed for the tanks on the proposed plan was that, and I'm quote unquote, the remedy proposed for tanks is to remove sludge from tanks and backfill the empty tanks. That's the only remedy that's given, or referred to at least. Problem with that is, so okay, we're removing all the chemicals from the tanks. What about the tanks themselves? They're contaminated. We haven't done any testing in the last 28, 27 years, so we can't really determine whether the tanks have leaked into the soil around it, so we don't even have any information as to whether the soil right below the tanks or surrounding the tanks are contaminated. By leaving the tanks there, I understand that they're supposed to be encased, or grouted, excuse me, I think that was the language in the proposed plan. We're still making ourselves vulnerable to the risk that that contamination in those tanks can still spread. So, in conclusion, Hanford, my nonprofit organization and myself, and especially Jerry, we ask that prior to reviewing the proposed plan, prior to finalizing it, that proper testing be done on the tanks to figure out what the contaminants are, whether there has been leakage, and also to test the area below the tanks, surrounding the tanks, and finally to remove the tanks. You can do this by basically breaking the tanks apart. You have to encase them before disposing them in a different landfill, but at least that way, at least most of the danger will be removed. And somebody mentioned the standards that have been used. Just one final thought. I noticed that on the proposed plan, kind of keeps going back and forth between the Superfund and then RECA. And I don't know how many of you guys know this. I was actually just informed that as of 1985, RECA is the one that's supposed to be applied. So the usage of any Superfund standards are just not enough and are actually not the ones that are required by law. So my final request is to make sure that RECA is being followed as it's supposed to. Thank you very much.
Thanks, Lindsay. Other comments?
I'll try to keep it really succinct. Do I need to say my name again for the record? Yeah.
Yep.
My name's Jacinta. I go to the University of Washington. I'm actually doing my honors thesis on the Hanford site, particularly the public participation aspect of your guys' plan. What I'd really like to see is more easily accessible information about your alternatives and all the other operations at Hanford. Just, so the people can gain, can know about it through your, I've looked at all of your websites and they're just kind of surface information and it's not easy to get like the really detailed things that are actually going on. Also, I was thinking maybe changing the format of the meetings and increasing outreach because I've gone to a lot of these and it's, a lot of similar faces, same messages being given, like it seems like the communication between different parties isn't quite as effective as it should be or could be. Also, I was wondering if any of you would be willing to meet with me and give me an interview to contribute to my thesis and my overall understanding of the Hanford site.
Jacinta, can I take the first 3 things you said as comments, and then the last thing, go ahead and
yeah, I might
go
have to
off
run
the
out of
record
here
and let
early,
these guys.
so I was just
they're
kind
kind of in receiving mode now, but I mean they can go ahead and answer that
Yeah,
question,
they can
but
do that separately.
we're gonna not put that into the formal comment record part. So I don't know, Emmy, JD, do you want to answer the whether you'd be willing to do an interview at a later date?
Sure, since I would be willing. Awesome. I have funding to go to Richland and everything, so I can contact you via email and stuff.
Okay, good.
Awesome. Thank you.
Thank you. Yep. Other comments? Yes, ma'am. Over here, Sonia. And please give us your name.
Hello, my name is Alira Walker, and I live in Seattle. And I'm here to say that the EPA and Washington Ecology should insist that plutonium, cesium, and other chemicals are dug up and removed at all of these sites, and they should have a cleanup standard for plutonium on Hanford's Central Plateau, which is just as protective as the level of the cleanup being used at Lawrence Livermore National Lab, because that shows that it is possible, or even the same strictness as they have for the Hanford sites that are closer to the river. And I think also this plutonium, when they dig it up, it should be sent to a geologic repository instead of just leaving it near the surface, because it will spread. And also I have something to say to the representatives from the EPA. It was interesting to hear this evening that this proposal isn't designed to protect the public, but rather it's to protect the workers. And so that was great that came out here. But I thought that the EPA was supposed to be concerned with groundwater contamination and concerned with the people who have to live around here in the future. The reason why I thought so is because it's not just called the Environmental Agency, it's the Environmental Protection Agency. And so that's why you guys at the EPA, the people depend on you to protect us when something terrible happens to our environment. And we trust you to make decisions that are a matter of life and death. And we're counting on you right now to insist on the highest possible cleanup standards, because anything less would be putting lives at risk. And so that's why we're holding you accountable for that. I guess also, if you people at the EPA really enjoy having this power over life and death, you might want to consider leaving the Environmental Protection Agency and joining the military instead. Because in the military, you can kill people legally.
Thank you. Other comments?
My name's Nancy Morris, and I just wanted to add a few points to what others have already said, because I want all to get out tonight here. First of all, I feel there is a great need for better remedies and actual attitudes towards removal of this waste. And what I mean by attitudes is that you might say, sir, that your grandchild might be trying to deal with this legacy, and I think that is very, I don't know, it's kind of a talk that doesn't really set well with me, because you can also easily leave the area once you realize that all is lost and go with your retirement that's been supported by the taxpayers. And however, if we were all required to meet certain standards where it's not just dependent on a few individuals or their stakes and all this, I think we'd all be better off in that we had a better citizen committee involved with this that included nonpartisan scientists and so on. There are definitely remedies out there currently being researched about the geological chambers being dug. I don't even know at this point if you've reached classification of any of the waste. There's not even a standard stability across the board at this point with the waste of plutonium. And the kind of energy that's being expended doesn't even equal the kind that was exhibited for the Manhattan Project that gave us the weapons of mass destruction that left us with this nightmare legacy. And that should be changed, and recognize that we have nuclear power plants all around the United States, around the world, and plutonium is ever present with us. We have to be able to deal with this in some fashion within our immediate generation, and be realistic that we may not be available to answer questions 100 years from now. And I'd like to end with one quote. This is from Dr. Kathleen Dean Moore, who's an ethics professor at OSU. We have an affirmative moral responsibility, individual and collectively, to leave the future a world rich in life-giving possibilities as a world we inherited. Thank you.
Thank you.
Again, my name is Margaret Swartzman, and I just want to say how impressed I am with Tom's comments and various other people here. definitely Hanford is a disaster, and we're all trying to deal with it. And I really do want to put my trust in you, and I have great doubts because the problem is so huge. And, but our intents must be to go beyond what we think we can do, to do as much as we possibly can to put the plutonium and other materials in geological stable environments. We've learned through other places the tremendous human cost of our nuclear idiocy. I mean, we can look at Chernobyl and all of the horrors of the people in Russia that live with for generations, for none of their, I mean, forests that cannot be entered for, 5 generations, maybe more. I mean, we don't want that to be happening in Portland, along the Columbia River. We must, it's not a roof on a house that we're suddenly having to find the money to put on the house in order to preserve it. It's greater than that. And we mustn't lose sight of that, no matter the difficulty of our financial times, no matter the difficulty of our political times. This is too central to our humanity. And that's all I can say. I mean, you know what I'm referring to, and you know that this is unborn children. We can't even imagine them yet.
My name is Jacqueline Sorgan, and Jerry asked me to put a face to the word cancer. And I'm hearing a lot of things about how we're putting carcinogenics into the groundwater, and it scares the hell out of me because I've been living with cancer for over 30 years. And I probably will not be around when this all comes to a head, and that's okay too. But the groundwater will be contaminated, and there will be truck route exposures to, and there will be carcinogens if the truck routes, if we make it the depository. Anyway, cancer risks from radiation are higher, especially for children and women, than previously estimated. 15 millirem of annual dose is now projected to cause 8 fatal cancers for every 10,000 adult males exposed. The risk to children is 3 to 10 times higher. The fatal risk to children using the groundwater, including Native Americans exercising their treaty rights to live and use the resources at Hanford, will be over 2%. If the Department of Energy goes ahead with its plan, there will be an increase in cancer risk to future generations using the groundwater tenfold. Exposure to even an extra 1 millirem per day would be expected to cause an increase in fatal cancers of about 2% for an exposed adult male and 3 to 10 times that risk for a child.
Thanks, Jacqueline.
Hi, I'm Eric Rosenfeld. I'm an intern at Hanford Challenge, and I'd just like to follow up what Jessica was saying about the difficulty of the understanding the proposed plan. I've started working on it about 2 weeks ago, and it wasn't until yesterday at about 4 o'clock that I finally finished just making a simple fact sheet, just fully grasping everything. Like Operable units, all that stuff is just very confusing, and if I was actually like tasked to work on it, and I feel like for someone who is not given that job, it's incredibly difficult to grasp anything that is being proposed in a plan that's even just 60 pages, and that is what I'm told is a very short plan. And so I just would like to see a bit more accessibility for the public.
Thanks, Eric. Okay, we're getting close to our time, but we want to be sure. Jerry, did you have a comment?
First off, I'd like to ask that the formal record include what went before the formal record began, because I think there was a lot of really terrific discussion and points being made from the public, and people are always hesitant to and feel like, well, I already said that, I don't need to say it again. And so we'd like to ask that everything all of you said earlier be in the record and be responded to formally later. And secondly, I think it is really important to build on the point that was just made, that the proposed plan is pretty not only incomprehensible, but the materials sent out, while there was a nice effort at making a guide, anyone who looked at an email that said proposed plan for CW5 is going to go back to sleep and not have a clue what this is about. The agencies were urged by the Hanford Advisory Board Public Involvement Committee and by stakeholder groups to put out a notice that said, proposed plan for cleanup of the plutonium liquid waste discharge sites. That would be understandable. It would be English. And you need to take this to heart. It's disheartening to me that because of the lack of time, these meetings were not set with 45 days notice per the public involvement plan. So we couldn't do a mailing in time to tell thousands of people about it. We had to rely on email, and that's very difficult to get people to turn out to. And your mailings and email basically talked about this proposed plan that was incomprehensible. If people want to look further and review the comments, as we discovered in the last 24 hours, the link was actually broken. If you search for the remedial investigation in the administrative record, you're faced with a search result of 600 documents, and you can't figure out which remedial investigation was actually the one relied upon for this proposed plan. Same with the feasibility studies. It's ridiculous. What would make sense is, why not put out a document that says, here's the link to the primary documents, so that you can actually read it and review it and see, did they actually report when they characterized the sites and what was in the sites? And that brings us to the difference between state hazardous waste law and the balancing act on the high wire of CERCLA Superfund, which doesn't have strict criteria, but we're fortunate because state law is also supposed to apply. And in this case, I'll turn over and walk over to John Price from Ecology. Hazardous waste law applies to every hazardous waste stored, treated, or disposed after 1985 on the Hanford site. We've had this conversation many times. Those storage tanks that Lydicy O'Brien was talking about still have waste in them. Over 1,000 liters or 2,000 liters in one of them. I forget what the quantity is in the other. It's still storing waste. Therefore, it's under your jurisdiction at Ecology as a RCRA storage tank. And it is subject to the more stringent standards that say you have to actually find out what the heck is in it. And if those are extremely hazardous waste, you have to remove the tank. And actually, there's no legal place to even landfill it in the state of Washington. Instead, we have a plan that says we're going to remove the contents, put them in a landfill where it might be illegal to put them in, and leave the tank, which might be illegal. For the cesium sites, we have a similar situation. For ditches, we have some of the ditches that took hazardous waste all the way till the year 1995. Now, the Energy Department, for the goodness of their hearts, didn't end dumping waste in these unlined ditches without treatment in 1995 because it was just out of the goodness of their heart about 30 years after everyone else stopped dumping liquid wastes without treatment in unlined ditches. They did it because they were sued and forced to stop in 1995. That's the point of having institutional memory. They're not very good at keeping commitments or following the law. And again, the hazardous waste law, for state and federal hazardous waste law, and our state rule says you have to characterize what is actually in a trench and the aerial extent of the contamination that is spread from it under our federal and state hazardous waste law, not just rely on characterization from 1970. In 1970, the Energy Department didn't believe, well, it wasn't a hazardous waste law for it to follow. In 1985, it still wasn't willing to say it was subject to that federal and state hazardous waste law. It fought it tooth and nail. So even if the data was collected in 1985, they wouldn't have done characterization of what the chemical hazardous wastes were. In 1970, they certainly didn't. They didn't try to identify which of these were corrosives, acidic, flammable, which of these need to be treated in what fashion and removed. We're talking about plutonium digging up 2 feet, but that same waste site has, I think, I won't go back and look it up, I think it's 300,000 liters of carbon tetrachloride in it, and hundreds of thousand liters of dibutyl phosphate, tributyl phosphate, and we don't even know how much hydroxylamine nitrate was put into these trenches. They haven't reported it. Just failed to characterize for it. But we know it was used and discharged. If we're following our federal and state hazardous waste law, we need to go back and recharacterize these sites properly and find out what is actually in them, and then apply the state law that says, for instance, on PCBs, the Energy Department says they won't move, we don't need a groundwater protection standard. Just like for plutonium, it won't move, we don't need a groundwater protection standard. Well, we need a standard, and the state has a standard for those chemical wastes, and it says, essentially, roughly, if you got level X, if the groundwater standard level is Y, you can't be more than 10 times it in the soil. We know we're way above that for these chemical contaminants. And yet they're saying, we'll just dig up 2 feet of soil, or we'll just cover up the cesium sites. That's not cleanup, that's a cover-up. We urge you to go back to the drawing board one more time. Once more into the breach, dear JJ.
Okay, are we good to call this one, you guys? Any burning comments? Before you leave, Jacinta especially, but all of the participants, there's actually a meeting survey on the back table. So we'd like you guys to pick one of those up and tell us what was good, what was bad, what worked, what didn't work, what we could do better in the future. Those are super important to the public involvement folks. And again, thanks for...
Yeah, I actually would like to make a comment.
Would you like to make a comment? Please give us your name.
Nice catch. Is this on? Hi, my name is Dee Frankforth. I'm a resident here in Seattle. 6 hours ago, I was not planning on being here this evening, but I found myself here and frankly quite riveted for 3 hours because it's really clear to me that the federal and state employees are here, are trying to do the best job that they can. But there have been a plethora of numbers thrown around tonight. $5.5 trillion from Tom. 240,000 years by a number of people. 21 sites. 21 sites out of, I forget, John Price, out of 300 or 600, 800? 21 sites out of 800. This is barely the surface of what has to be addressed. 21 sites, by my calculation, at best, we had 21 non-paid people here tonight to talk. How in the world can you expect the public to be able to comprehend, let alone respond to something of this magnitude? It is appalling. And I can only say, with $5.5 trillion spent to create this issue, there has to be a commensurate amount of will and money to clean it up.
Thank you, Dee. Thanks, everybody, for coming out tonight. And please get a meeting summary or survey and let us know what you thought.